Thank you very much for the invitation. My name is Paola Lucero. I'm currently working at the Palace University of Olomouc. And in this presentation, I will present my results concerning the study of objects of cultural heritage using pyrolysis GCMS. And as I know that maybe this is a topic that it's a bit far away from yours, I would like to start to present the reasons and the information that we can extract from studying the material part of artworks. So the first point is to understand the master's technique and everything that comes along with it, which means what was the budget, what were the materials available to the artist, what technology he developed, like for instance with a great artist. And the second point is to identify alterations. Maybe you know this very famous Vermeer painting. For centuries, the little cupid that it's on the back was covered, and only until recent decades, scientists discovered that this was some modification that occurred after the execution of the Vermeer. So it was somebody else who covered the cupid. So this is why it is somehow interesting to understand these materials. We can also assess authenticity. Sometimes there are materials that had been added to the palette that it's available for artists in specific centuries, and we can trace back these moments, and we can see if the moment of execution match the materials that we found in the artwork. And we can reveal potential changes. You know, during centuries, materials modify, interact among each other, and we can detect sometimes, for instance, metal soaps, and it's important to assess and to identify what was the original colors and the original texture that was in the artwork. Now, regarding the binders, binders give the name to the technique. For instance, when you use as binder a gum to agglutinate pigment and apply it, you are talking of an aquarelle. When you use oil, you are talking about an oil painting, and so on. So this is the kind of information that we can extract, and it's very important for the conservators in order to undertake some interventions that won't harm the artwork. Now, what are the challenges that arise when you analyze this type of materials? Well, yes, this is a sample. It's around 1 microgram, and as you see, this is a layered sample, which means you have heterogeneous composition. These materials, as I say, have had the time to interact with each other. Some of them had migrate, and we have also some mineral matrices. So when we start an analysis of this type of sample, we really need to be sure that we have a very consistent, efficient method for analysis. And also, we have limited sample. We cannot make any mistake. And I talk about binders, but organic materials can also be varnishes and consolidants. And you see how complex can be a single piece of a sample of artwork. Now, from the molecular point of view, what are these organic materials? Well, they can be proteins, and they can be polysaccharides, which means we have a polymeric material. In the other hand, we can also have glycerolipids and natural resins. These resins are non-originally polymers, but upon curing, they will develop a network of polymers. So if we want to apply a technique, a classical technique like GCMS, it's not possible. We need to undertake some hydrolysis, and for some of the compounds, we need basic hydrolysis. For others, we need acid hydrolysis. And as I said before, the samples are limited, and sometimes it's better to undertake an analysis in a single sample, and this is why pyrolysis is ideal. So this is our equipment that it's in our lab, and we have our GCMS coupled with the quadruple single detector. These are the models, and here we have the pyrolyzer that it's directly mounted on the injection port. And this is the interface for the pyrolysis. Yes, this. We select the parameters that fit better. We use the single shot. This pyrolyzer had the possibility for to make a bulk gas analysis, which means you have an injection without separation in the chromatographic column, or you can make a multi-shot analysis or a single shot. I preferred for this analysis the single shot. We use the NIST and the MSD for processing the data. And now regarding the sample preparation, it's super simple. What you need is this little cup. Here you have the sample. We are using thermally assisted silylation with HMDS. We simply put the sample here and we put the silylating agent. And then here we put the sample and we start the run. So this will be the presentation about the Betchov Teplow murals that are in the chapel of Betchov Castle. So as you see, this is a mural painting, and I don't know if you see it, but the finishing is not quite the one that you would be expecting for a fresco painting. This has some sort of glossy finish, so the curators imagine that this was a seco. A seco means that there is some organic binder there. And with pyrolysis, we analyzed several samples. This is one of the samples. And this is like a very, very classic profile for egg. So we have here the hexadecanoic acid, which is the biggest signal, and the stearic acid. So these proportions are very, very typical for egg. So we conclude that the binder used for executed this mural is proteinaceous tempera. So now we have another sample coming off the same mural, and additionally, we find glycerol and phosphate. As you know, the proteins that are in egg yolk have a very high content of phosphates. So this comes from that, and this confirms also the proteinaceous tempera execution technique. Now, this is another object that comes from Orte. Orte is this beautiful medieval town that it's near Rome, near the Via Appia. And we have some object, and we have some samples from it. And as you see, the pyrogram is much more complex. So we have these first signals that come from fatty acids. These fatty acids are not markers by themselves because they are present in so many materials. But we have this particular one, the undecanoic acid, and this acid is not present in all the natural oils that were used by the classical masters. I mean, linseed, poppy, and walnut oil doesn't have this compound, but castor oil does. Castor oil is this oil that is used for the preparation of industrial paintings in contemporary works. Additionally, we have these two signals that correspond to phthalates. So this confirms the presence of some modern material. Finally, this last part of the chromatogram had the signals of abiotic and primaric compounds. We also have phenanthrin, and I will explain you something about these ones. We can gather information about the technology that was employed to prepare some painting, that's what I say. And here I am presenting the skeletons of these molecules that are markers for the terpenic resins. Well, when these molecules degrade, this structure turn to aromatize, and then the formation of retin arises, and this can be a marker of either aging or heating. Given the context, thinking that is a modern paint, what I'm seeing in the pyrogram, I could tend to say that this painting was prepared by heating. So my conclusions would be that PGCMS is a rapid, simple technique that allows to analyze samples without the wet working up, and this avoids potential contamination and potential loss of sample. It allows the determination in a single step of small molecules, like can be fatty acids, and of polymeric materials that can be the components from the resins. Compared to the wet technical treatment, it's much less expensive. And it overcomes also the disadvantages that you have when you use the wet procedure, because some interferences can hinder the interpretation and the analysis of these molecules. So I thank you for your attention. I thank to my colleagues, Petar Bartak, Jana, and Karel. And thank you very much for your attention.